4th of July is coming up, and everyone's gonna have some nice ice-cold beverages. But you know where it won't be very sunny is about 500 million miles from here near Jupiter. NASA's Juno spacecraft will be arriving there this 4th of July, making it humanity's most distant solar-powered spacecraft. And all of its systems, including keeping it warm, are powered by about the same amount of power this blender currently uses. How is that even possible so far away? Let's find out on this episode of Crazy Engineering. Right, we're here with Tracy in this huge room. Hello, Tracy.
Hello.
Can you tell us a little bit about the room that we're standing in?
Yes, we're here in High Bay 1, which is JPL's oldest, largest clean room where we assemble spacecraft.
Okay, and what are we standing in front of today?
We are standing in front of one of the test units for a Juno solar array. Juno's a mission that's going to Jupiter to learn more about the planet and how it was formed.
So this is a full-scale test unit, and it's one of 3 on the Juno spacecraft. Why does it have to be this big?
Jupiter is 5 times farther away from the sun than the Earth is, and the amount of sunlight you get is decreasing by the square of the distance. So instead of 1/5 the amount of power, we have 1/25 the amount of power. So we need to have a lot of area on our solar arrays because the spacecraft is so far away from the sun. And also over the last 20 years, we've had about a 50% increase in solar array efficiency, and that makes it easier to do at that distance. If we had these solar arrays here on Earth, they would actually generate about 14 kilowatts of power. But all the way out at Jupiter, they only generate about 500 watts of power.
These things are so huge and heavy, I imagine it's a bit of a challenge to test them on Earth before you go to space.
Yeah, these solar arrays weigh about 250 pounds apiece. Here on Earth, when we tested them, we only deployed one at a time because we didn't really have a clean room facility big enough to do all 3. And we also had to do them sideways and support them on these posts with wheels on the bottom so you could gently roll them out and make sure that the hinges and the dampers and all of that were working just fine.
Juno is one of the largest spacecraft I've ever seen. How do you package that up onto a launch vehicle?
Our spacecraft is about 65 feet across, the array's deployed, and that certainly wasn't going to work. So when we launch the vehicle, it has to be folded up small enough to fit into the nose cone of the rocket. And you'll notice that the cells are on the inside, and so they wouldn't be getting any power from the sun. So that was a really interesting time for the team during launch, is knowing that we had to make sure the arrays were deployed to get sun, or the spacecraft would just have died.
So we're deployed, we're absorbing energy. When do we hope to arrive at Jupiter?
We're going to arrive on July 4th of 2016, and the mission is going to last until February of 2018.
Great, we'll be watching. And you guys out there, stay tuned for that mission getting to Jupiter, and check back again for some other crazy engineering.